Hello, Assalamu alaikum, dear friends. Welcome to Online Pharmacy. This is the logo of our channel. Don't be afraid of it. Now we are discussing today's topic, rheology. What is rheology? What is the fundamentals of rheology? What are the essentials? What is the importance? What are the effects? And which properties are going to be affected by rheology? It is a topic, as we mentioned, that is beneath that heading, that's physical pharmacy. Physical pharmacy is a most important or the fundamental concept of pharmacy. If you are a pharmacy student, not a big deal. If you are a physical pharmacy student, if you are going to be any for platform for that pharmacy or anything else, whenever we are dropping with a topic now we are discussing the topic rheology. So when we are going to deal with the rheology, rheo, it's comprising of two words. First one is rheo and the second one is logy. Rheology, rheo means study or the flow. Which type of flow? Flow of behavior, flow of liquids, flow of semi solids. Okay, this is the rheology. Rheology, these are comprising of two words. The first one is rheo. Rheo means liquids, and logy means study, and it means liquid or semi solids. The second one that's going to deal with that is what is the definition of rheology. What we are going to study in under this heading, what's the rheology? Basically, if you are having a question in your exam, then you can must simply write it that it is a flow behavior of the liquids or semi-solid. It's enough. But what are the factors which cause this? There's nothing, any force or any magic which can cause your liquid to become thick, your liquid to become too runny, and your liquid to become solid without any optimum temperature, pressure, condition, or without anything. So there's nothing or such kind of force exists in that universe. So there are some factors which cause these changes. So we are dealing with that. What are these causes? What are these factors? So what is this slide? That's rheology is the branch of physics, the science that deals with the deformation. Remember what is deformation? Deformation is the flow or the change. Deformation is the change of flow materials, both liquids and solids. Or in this study rheology, we study that primarily we are dealing with liquids rheology. Remember, for solids, we have another term which is micromeritics. What is micromeritics? Micromeritics is the branch of pharmacy, physical pharmacy, which contributes to solids, their particle size reduction, their properties, their flow, their behavior. But we are dealing here rheology for liquids only and for semi-solids only. What are the liquid dosage forms? Liquid dosage forms, that's the liquid. Liquid dosage forms are preparations, are injections. For intravenous preparations, intramuscular preparations, these all are comes under the heading of liquids. Syrups, you are thinking that syrup is a liquid? No, syrup is not a liquid. So maybe emulsion, it may be suspension. Basically it's a suspension, so it's a semi-solid. We can deal it under the heading of semi-solid dosage or liquid dosage forms. And what are soft solids? Soft solids are basically semi-solid dosage forms. What are these semi-solid dosage forms? These are ointments, gels, creams, paste. The paste, the regular toothpaste, the creams which you are using on your face or under the body part on your skin, or for topical or dermal preparations. These are comes under this heading of rheology. The next thing which we have mentioned there, it's the plastic flow. What is the term? Plastic flow, which we are dealing in the next slide. Deforming means change, as we have mentioned here. Elasticity is the change or change in appearance, change in place, change in distance or something. Applied force, as the word indicate, the force you are going to be applying. If suppose if you are going to be shift your decoration piece or your furniture, then you have to apply it force. There's nothing such existing except that that's from the sky there just comes down and drag your furniture, that she or he want to deform it, that I have to do. No, there's nothing such kind of force exists. So you have to put an applied force on that. So what are these forces or what are these factors? Why we have to study this? Yes, the basic question. When I was in that year of pharmacy, I was also thinking that why are we studying the theology or for the stats, for the same stats or mathematics. I was be like, why I am reading this, why I am learning this, why I have to be appear in that exam. So these all are the fundamentals or concepts which are important for pharmaceutical industry as well as in hospitals, in dosings, in formulations. According to APIs, what according to APIs? Active pharmaceutical ingredient. This is the another topic. Inshallah, I will discover in my next video. So why we have to study rheology? Because it has an application in pharmaceutical industries. As I have mentioned there, importance of rheology. We have to read, write, learn or think about importance of rheology and what are the fundamentals. The another name of fundamentals also essentials, that what things are important or much most important or powerful for formulations in pharmacy. So now come to that. What are these points or why I'm emphasizing on that too much? Essentials of rheology. What are these essentials? The manufacturing and handling. As you very much aware about the manufacturing, what is the manufacturing? Manufacturing is the preparation of something from formulation to packing. The steps which are including between this, that from APIs, active pharmaceutical ingredients, by taking a base, by taking an ointment, by taking all the physical equipments which are needed for their preparation, and to the final step which is a handling, packaging, storage or dispensing, etc. So rheology, if your rheology is basically directly related with viscosity. Rheology is a change in behavior. Which kind of change? If you consider a liquid have a which type of flow? That's a linear flow. Nothing the hindrance, nothing can be going to be disturb the flow of water. But if you are going to think or taking an example of honey, then honey has a viscosity much more greater than that of water. Why? This is the flow behavior. If you are pouring a water on the ground or on a flat surface, the water will runs quickly as you want to get it your home. No, no, no. I'm not mean to I don't mean that. If you're pouring a honey on a table, then what the honey will be do? The honey will move slowly like a turtle. Why? Because there's a hindrance in their flow, and this hindrance is called viscosity. We are dealing in our next slide. Importance of what are the importance of rheology? Okay, now importance. I can try to explain you the most of best. Formulation. What are formulation? Formulation is a preparation. If example, if you are mixing a 2 grams of something A, compound A, and if you are mixing a 3 grams of compound B, you have to formulate it. Means mix it in a. If suppose you are going to mix it in a mortar and pestle, then mortar and pestle. These both samples A and B should have the enough consistency to be titrate. If you are taking one is too much solid, sample A is solid like stone, and sample B is like water, then how can you incorporate both of these? So the rheology, the flow, the behavior, the appearance of that liquids or semi-solids much more important. Formulation. Coating of tablets. If you are going to prepare an preparation or prepare a liquid or prepare a semi-solid preparation, which are paste or gel, if it is its consistency is too high to coat the tablets, then the tablet will not coats as you wished. Why? Because when you are when you are making a preparation which is too thick or which is too much runny, there are two conditions. Maybe it will runny or maybe it will too much thick. If it is runny, then the coating is too much thin that it cannot protect. Why we are coating? We are coating for protect our mucosa, for protect our intestinal lining, for protect our stomach acid, or to protect the degradation, means breaking down of that product or that active ingredient in our stomach. So we are coat. If the coating is too thin, then our stomach acid will easily degrade that and cause the absorption as much earlier as we required or needed. So coating is a much more important, that the material which is going to be coat the tablet is most efficient or most effective. Yes, like water, and this is the honey. Can you observe the flow of water? It's too much linear, it's too much flowy, that you cannot need anything to push it to for flowing, move it fast. And honey, this is the honey. You can see that air entrapment is this between honey. Why this is entrapment? Because they are slowing it slow speed that the air particles are going to be incorporated in between them and causing their flow much more slow. In the liquid, air entrapment is there, but because of water is comprising of water and oxygen, they are completely miscible with each other and they exist in one phase. What is mean by one phase? That is, no water is not in another phase or another position or another appearance, or the oxygen is not as a air bubble in water. So they are completely miscible and forming a one phase liquid, that is a completely one appearance, completely one shape, completely one behavior. So why we is therefore we study rheology. For emulsions, if you are going to prepare an emulsions, then important on emulsions we are, inshallah, I'm going to be taking another lecture or another video with you. Suspensions, for suspension, these are also semi suspension or liquid dosage forms, but it consists of two phases. The one is dispersed phase and other is dispersion medium. If for example, if your dispersion medium or dispersed phase, if your dispersion medium is too much thick, then the dispersed phase is not going to be incorporate with it at its maximum and causing the separation. If you are prepare suspension and it has not, you cannot change or you cannot observe its rheological property as the pharmacy requirements are mentioned on that topic. Okay, the suspensions in fluidity. What is the fluidity? Fluidity is the reverse. What is the fluidity? Fluidity is the active or most fast flow. How this most fast flow can take place? Contain a beaker. If you having a beaker, suppose you have a beaker and you tilt that beaker too much, the water can flow directly on the spin without any hindrance. But suppose if you are going to take honey, the fluidity of honey, if you are taking tilt the container of honey, there's a honey inside, and you allow the honey to get incorporated in it. The honey will slowly comes out and doesn't reaches that stage, which is occupied by water in only 1 second. But this honey will take probably 20 seconds to flow. So its fluidity is much less. Why? Because of this rheology, because of its viscosity. So that's why we compare rheology and viscosity with each other. Pouring. What is the pouring? What is the pouring? Pouring. Pouring as simple the mentioned pouring. Pouring as we mentioned in that slide. If you are pouring, this is the container. Ointment is present in this container, and if you have poured this ointment, as you know that ointment is thick, little bit more thick than honey, so it takes time in pouring, and you have to fill it in a tube. This is the tube which is to be dispensed. The time taken by the ointment to fill in this tube will be much greater as compared to water, so it will affect the property. Why? When you are pouring or filling the ointment in this tube, suppose you have filled this much in tube, and now there is a air entrapment in between them, and again the ointment is filled. So it affects the manufacturing. How manufacturing are handling it cannot be weighted as we have standard, or as we have set the standard. Titration. What is titration? Titration is the most basic concept we are studying or dealing with. Titration, that is a neutralization. Titration, it is basically a neutralization. Neutralization of what? Neutralization of strong acids, strong bases, weak acids and weak bases. Now the next slide is as we have discussed. Now we are come towards viscosity. We are continuously again and again dealing with rheology, viscosity. Why? Cause viscosity. Why viscosity? If rheology is the flow of liquid, if liquid is too thick, we say that viscosity is too much high. What is viscosity? That is the hindrance in their flow is much greater. Viscosity effect. Change the shape. Viscosity affects and change the movement of the neighboring partition relative to one another. Change in deformation of fluid with respect to time. Deformation, the change, like we have discussed earlier in water and honey. The time taken by water to flow and the time taken by the honey to reaches at that point is different. Why? Because it's of viscosity, it's of flow behavior. So viscosity denotes opposition to flow. How much resistance is there in the pathway of the fluid or the semi-solid dosage form to flow, or the hindrance created. Viscosity denotes position. Okay, we can denote with this is the nu. This is the nu, as you have mentioned that this is a nu. This is nu. Nu is equals to F over G. What is this F and what is this G? Don't going to be confused with this. This N is the coefficient. Which type of coefficient? It's also called eta. Coefficient of viscosity, it is eta. And F is the shearing stress. What is shearing stress? I will discuss in the last slide. And G, what is the shear rate? So viscosity is the depends upon two things, that is shearing stress and the shear rate. Remember, they both are directly proportional to each other. Whenever the shearing stress increases, the rate of shear also increases. What are the viscosity factors that affect? Viscosity is directly proportional to temperature. As I mentioned there, viscosity is directly proportional to temperature. Directly proportional means whenever you are increasing temperature, viscosity is also going to be increased. But it is not for liquids. It's not for liquids, and when it's directly proportional to gases. But in gases, when you are increasing temperature, viscosity is also increases. And temperature for its exceptional case, and viscosity is inversely proportional. It's directly proportional and it is inversely proportional. Okay, understand? So viscosity is inversely proportional to temperature for liquids. If you are taking a liquid and heat the flame or heat the bulb or heat the flame, that this is the container, and container containing a liquid, and you can apply a sufficient amount of heat to that container. When as the temperature increases, the viscosity is going to be decreases. Why? Because the intramolecular force of attraction between the molecule, this is the container, these are the closely packed molecules. Whenever you supply a sufficient amount of heat to that, these molecules move apart from each other. There is a gap in between them. This gap causes the decrease in viscosity. And for gases, the exceptional for gases. Why for gases? Because gases have direct relation with temperature. This, can you please correct this for me? Having a direct relation, having a inverse relation. Okay, understand? For viscosity of temperature, its unit. What its unit? Its unit is poise per dyne. Poise. Poise is the name of scientist. Or dynes into centimeter, or centimeter per centimeter cube is the unit of viscosity. There is an exceptional example of methyl cellulose. That whenever you heat a methyl cellulose, I can write it there. You can note it down. It's also important for MCUs. Methyl cellulose. MC. Methyl cellulose. Whenever you heat, this is the amount of heat provided to methyl cellulose. Whenever you heat a methyl cellulose, a temperature increases. On heating, it forms gel. On heating, it forms gel. On heating, it forms gel. This can be converted into heating into gel, and this gel on heating can be converted it into temperature on heating. Okay, this methyl cellulose converted into gel. On further heating, it's converted into more thick gel. So gel is more viscous than liquid, so it is going to be increase its viscosity on direct heating or by giving temperature. This is an exceptional case for liquid, but for gases the relation is directly. When you increase temperature, the viscosity of gases also increases. How we can determine this viscosity? The first most general question is, there are different types of viscometers. Okay, now come towards this again. This is this Poise. Poise is the scientist name which can give a relation that how to find this viscosity, how to find the value of viscosity. So unit is as it written Poise. It's also known as dynes into centimeter per centimeter cube. 10 Poise. 10 Poise is equals to 1 Pascal into seconds, or which gives us the centi Poise. Now, what is the Newton's law of viscosity? Newton is a scientist. How viscosity comes into our reaches, or comes to in our reach, comes to in our circle, or how we can going to be discovered. That's according to Newton's law of viscosity. As the Newton's law of viscosity states that, again the word there you are seeing, that's the shear stress. This is the shear stress. Again you are come at this word, inshallah we are going to discover at this end. What is shear stress? Shear stress is directly proportional to velocity. Whenever you increase the velocity is also you can understand it by it is a force. It is a force applied velocity. Shear stress between the two adjacent layers of fluid is directly proportional to the negative value of the velocity gradient. What is the velocity gradient? Means it is a barrier. Velocity gradient is a barrier. As the shear stress is applied, the velocity barrier, negative value of the velocity gradient, means the velocity gradient is going to be decreases between the same two adjacent fluid layers. This is statement, you have to learn this statement. Mathematically, this is Ty. This Ty is tau. We can learn or say it as a tau. tau. Tau is equals to the negative value, as the statement indicates, the negative value of velocity gradient. dv. dv is the change in velocity upon dy is the change in displacement. That is understood when you are applying force to something. Suppose this is a piece of anything or a matter. Sample A. You are applying the force on that. So from this place it shifts to this point. This is the displacement traveled by this object. So the change in velocity upon the change in distance is given by the Newton's law of viscosity, where here we mention that mu. What is the mu? Mu is the constant of proportionality known as dynamic viscosity. And T, what is the T? Is the tau or a shear stress. हम इसको हम कहते हैं shear stress. dv is the change in velocity and dy is the change in distance, as we have noted. The new unit, you have to learn this unit. Why is Newton into second per meter square? Meter square is for the area or the distance dy, and Newton into second is d for velocities. Newtons into second. Newton's law of viscosity, the unit you have to be learned, that is Newton into second per meter square for Newton's law of viscosity. How we can measure this viscosity? According to the most important and the most useful apparatus they have mentioned there, Oswald viscometer. This is the Oswald viscometer. Don't going to be confused with this. This is an Oswald viscometer. Now it has two bulbs. This is the Oswald viscometer. This is the bulb A. This is the tube, and this is the bulb B. This is the tube, and these are the two linings. Okay. These are the 2 points. This is the upper mark and this is the lower mark. Why I am mentioning this, I will tell you. Now the pouring, this is the liquid in a container. You have to determine its viscosity. So you can take this liquid from this pipe by sucking. No, by not sucking, you can also pour it at this point. Now this bulb is filled with this liquid and reaches there. As this is the height, is going to increase, so liquid cannot penetrate or cannot move upward automatically. So at this point there is a pipe for sucking. You can suck from that point the liquid. By sucking, the liquid can move upward and fill that bulb and fill the place. Now you can allow this, the volume is going to be decreased in that pipe. So now in this, the flow material or the flow of liquid from, now you can suck, and this from point A to point B, the liquid can be present. So now you can stop sucking from that point, stop sucking. The liquid move from, this is the point A, this is the point B. The liquid move from point A to point B. In what time? In what amount of time? In which time? The time is important. You have to denote this time. Why? Because this time बताएगा ये time आपको कि कितने time में आपका fluid जो है वो point A से point B तक आया है. So ये time आपको denote करना है, because in formula we need this time. Then this is very important for the determination of viscosity. And we compare this viscosity with the standard one. And usually we take in the standard as water. Similarly, we take the 3 readings in that. Inshallah, on Oswald viscometer, I will make another video for you, or for your convenience, or for your practical exam. It is much more important. Now, the types of viscosity. What are those? So, Oswald viscometer is the main apparatus used for denoting the viscosity or determining the viscosity. How many types of viscosities are there? There are 2 types of viscosities. 2 types. What are the kinematic? The first one is the kinematic viscosity, and the second one is dynamic viscosity. You cannot find a much more difference in between these 2 viscosities, but let me clear you. That's the kinematic viscosity. The viscosity of a fluid observed due to gravitational force. It's an automatic force that you can observe this force. You can automatically calculate this viscosity without any applied force, because the only force acting on this is the force of gravity. And why we mention it here, density? Because density is increasing, or which density is decreasing. Maybe it increase or maybe it decrease. So it affects the viscosity. How? Example in kinematic viscosity. Example, you taking a sample of water. This is the water. Example, just suppose it having the same dynamic viscosity. This is the ethanol. Both of these have the same viscosities. कौन सी viscosities? Kinematic viscosities. No, it is not possible, dear. Cause the density of ethanol. Cause why? Cause the density of ethanol is maybe greater, maybe as much higher as compared to ethanol. So this is ethanol, this is water. Ethanol, this is ethanol, and this is water. Kinematic viscosity under the force for water is different, and for ethanol is different. Why? Because they both have the different densities. So kinematic viscosity may be affected by the gravitational force, may affect by density. These are the two factors which affect the kinematic viscosity. Now come towards the dynamic viscosity. What is the dynamic viscosity? Dynamic viscosity, as they mention here, that is an applied force. When you applied force, the dynamic viscosity may be increased, viscosity may be decreased. What is the fluidity? Fluidity is the opposite to viscosity. Opposite. What is viscosity? Viscosity is the hindrance, and fluidity is the free flowing. हट जाओ, सबको मार गिराऊंगा मैं और एग्जामिनेशन हॉल पहुंच जाऊंगा. ये वाला स्प्रेड चाहिए होता है फ्लूइडिटी के लिए. ये दिस इज द फ्लो ऑफ फ्लूइडिटी. ओके, सो व्हाट इज द रीजन व्हाई द फ्लूइडिटी takes place? As we know that why viscosity, the reason of viscosity is the strong intermolecular force of attraction, and for fluids, the weak attractive forces, the weak van der Waals forces of attraction, the weak electrostatic force of attraction, these all are the forces going to influence the fluidity or viscosity. For viscosity is much higher, consistency is much thicker when the intermolecular force of attraction between the two molecules. Let's suppose this is the container and these are the molecules, they are closely packed. Why? Because they have the greater intermolecular forces of attraction between them, so viscosity increases. But for liquids or fluidity, for the concept of fluidity, these are the two molecules, they are apart from each other, having a air entrapment between, having a gaps between them, having a weak van der Waals force of attraction, and they are not tightly bound to each other, so they can easily flow. Like you have friend, if you have a friend and you are going to canteen, then you would try that your friend will always going with you on the canteen, so you are bounded. Why? Because you have a strong bond, the best friendship bond. And if you don't have any friend, you are alone in the university, then you are free to go where you want to go. So this is the same phenomena for fluidity and viscosity. What are the reasons? The reasons are discussed is the same. Shear stress. Now we have discussed the shear stress. For shear stress for what? Now this is the shear stress. Here we discuss the shear stress. This F is the shear stress and this is the G. Now what is the shear stress? It is the force applied parallel. Suppose this is the container. It contains a liquid layer. This is the liquid layer and this is another liquid layer. This is another liquid layer. So they are moving parallel to each other. These are the two fluid layers, 3 fluid layers, or maybe 4 fluid layers depending on the liquid. So the layer of liquid or any material, they are parallel to each other. They are moving parallel, so called shear. Shear is basically a force. This is the shear of force or shear or force between the two parallel layers. So the force between them two layers, it's called a shear stress or shear force. What is the formula? Formula is T. We can denote it as tau, as we have discussed earlier. Tau force, F force per unit area. This is the force per unit area. How? This is the unit. This is the water. Suppose this is a water. This is the unit area of that water. We are applying force. The force is parallel. We are applying force parallel. This is the plane or surface of liquid. This is the plane or surface of liquid. How it's going to be deformed per unit area? When you applied a force, it can, this is another layer, suppose. It can shift towards there. There is a difference in their distances. Understand? Whenever you applied shear, there is a change in position, there's a deformation, there is a disposition of the parallel layers of the fluid which are in contact with each other. There's a gap in between them in which the shear stress or shear force is present, which is applied force per unit area. We can written or denoted it as. So what is this F in this formula? F is the force and A is the applied parallel to applied force. The force which is required to displace the parallel layers of water, parallel layers of any liquid. What is shear rate? It can be defined by taking two parallel surfaces. Suppose shear rate is dV. Don't be getting confused by this messy equation. I will overwrite it there. I will write it over there. This is, so what is this? This is the Y, this is the Y, this, okay. This is the D over D. What is the difference in both these? The upper one is the dV and the lower one is dr. What is dV and what is dr? Don't get me confused. I'm gonna clear you. It can be defined by taking two parallel surfaces. Suppose this is the one parallel surface and this is the second parallel surface. They both are equal. Parallel strains, okay. This is the one surface and this is another. This is the one parallel surface, this is the second parallel surface of your. One is stationary, this is the base of container. Suppose this is the base, this is stationary and this is a moving liquid inside the container. This is the base of container which is stationary and this is the liquid which is moving, or the liquid layer which is moving. This is the change in whenever the parallel force is applied, is the shear rate. Why we are shear, the word is both same for the shear stress or the shear rate. Rate is the, when we are going to be talk about rate indicates that's a time dependent reaction. It depend on something, that's the distance, it depend on time, it depend, any relation is there in between them. So we are going to discuss in this. What is the shear rate? Why we are it is Y, we can denote it as Y. What is Y? Y is the shear rate. We can define that shear rate is the dV over dt. That's the difference in velocity between the two parallel planes of liquid. There's a difference in velocity. The one is moving with another velocity and the lower one is having a zero velocity. So at zero velocity it is not moving, and at the viscosity increases, the liquid layers start to move. So there's a shear rate, force per unit area. As in the beginning of our lecture, I told you that force per unit area is directly proportional to change in velocity upon change in radius, change in distance. Whenever you shear force is increases, यानी force per unit area जब भी increase होगा आपके पास, तो आपका distance travel करेगा, parallel layer जो है liquid की distance travel करेगी, और distance travel कैसे करेगी? जब उसकी कुछ velocity होगी, with some visible velocity. So whenever you applied force, the velocity increases and the area, force per unit area, so the distance traveled by that fluid. So this is the change or the rate. dV is the change in velocity of moving plates and dr is the distance between two parallel surfaces, as Fa is directly proportional to dV over dr. Understand? Thank you so much guys for watching more videos and having more concepts for clear with me. Please do subscribe and share my channel. Allah Hafiz. Take care. Bye bye. See you. Must watch and must listen. Online pharmacy. Stay tuned.